Hey class, I wanted to talk to you just briefly about the Universal Law of Gravitation, or Newton's Law of Universal Gravitation. So what it is it's basically a way of investigating or calculating, really, the gravitational attractive force between any two objects. So far, anytime we talked about the force due to gravity, we've really just been talking about an object's weight. And we've said that its weight, let me try that again. We've just determined that an object's weight is equal to mass multiplied by gravity, where gravity is 9.81 meters per second squared. But that equation, this equation here, assumes that you're on Earth's surface, that you're near the elevation of sea level. That's where g equals 9.81 meters per second squared. And if you move further away from Earth's surface, then the gravitational attractive force will actually decrease. And so you would actually weigh less on top of a very tall mountain than you do at sea level. And you'd weigh much less if you're in a rocket ship orbiting the Earth than you do here on Earth. Gravity doesn't just go away, but the force due to gravitational attraction would be less. So the way that we're able to quantify the force due to gravity is shown in this equation. The force is equal to the gravitational constant, capital G, multiplied by the mass of your first object, multiplied by the mass of the second object, and then divide by the distance between those two masses squared. So the way this is written as an equation is shown here. The gravitational attractive force between any two masses is equal to this constant multiplied by those two masses multiplied together, and then divided by r, the distance between them, squared. So g is a universal constant, the best that we understand for the way the universe was created by God, and that g value is equal to 6.67 times 10 to the negative 11th newtons times meters squared per kilogram squared. Those units look weird, but what they do when you plug it into this equation gives you newtons for the force. All right, so again, this quantifies the natural attractive force between any two masses. We usually talk about gravitational force in terms of things like, the gravitational force between me and Earth, which is my weight, or between a spaceship and Earth, very large things. But you can calculate the gravitational attractive force between you and your water bottle, or you and your cell phone, which is probably high. No, just kidding. Or between two different people, or between two planets, or a moon and a planet. All these different things will all have a gravitational attractive force. So I just want to show you a quick example problem of this idea that where you missed because of class being canceled. So here you're asked to determine the gravitational attractive force between two students. Let's say one has a mass of 55 kilograms and the other has a mass of 75 kilograms, and we're going to say that they're 0.75 meters apart. So to solve this example problem, what we need to do is calculate the gravitational force. So the gravitational force is going to be equal to g, the gravitational constant, so 6.67 multiplied by 10 to the negative 11th power newtons times meters squared divided by kilograms squared. So that's all g, multiplied by mass 1. So mass 1 is 55 kilograms, multiplied by mass 2, which is 75 kilograms, and then divided all that by r squared, so in this case 0.75 meters squared. And if we do the math, we should be able to figure out that the force due to gravity between these two students should come out to be equal to 4.9 times 10. I'm running out of space here, so I'm going to shift us over a little bit. Times 10, I'm going to rewrite that. So 4.9, take two, 4.9 times 10 to the negative 7th power newtons. Oh boy howdy. So very small magnitude of force, but still box worthy. And that's because they're two very small masses compared to this very large or very small gravitational constant. So it's only if you have extremely large masses, like the mass of the Earth, that you're going to have high forces due to gravitational attraction. But anyway, this should help you with one of the homework questions. So enjoy and let me know if you have any questions.